while you're doing that, I actually want to look at the sort of properties around simple harmonic motion. So I won't jump into the problems just yet. I will just sort of get a bit of understanding around what simple harmonic motion is and what sort of properties there are surrounding it. Yeah. This is, I guess it's like a spring with a mass at the end of it. And as you can see, if it's kind of starting at the extremity, that's how we create our closed curve, going up and down. Now, some more kind of interesting things, some properties I want to think about are its velocity and acceleration, like what's kind of happening with this velocity and acceleration. Let's look at, for example, the velocity first. So remove the position. What's going to be modeled now is its velocity, right? Oh, where'd it go? There you go. Cool. All right, so that's like a sine curve, yeah? So it's a negative sine curve, as you can tell. Now, what can you tell me about what's going on here? So what I want you to think about is like, when is this velocity like the fastest? Or when is it 0, for example? Say again? At the, yeah, it is, but like, where is the mass?
When the actual ball thing is at like the end or at the top.
Right, so at the extremes, right? So it is 0 at the intercepts, but this occurs at the extremes of the motion, right? So you can see it's approaching, this mass is approaching the bottom, and then it's heading back up. So right there at the extremes of motion. That's the first property I want you to note down. I'll write all of these down too. So where's an eraser? Let's get rid of all this.
Velocity is 0 at the extremes.
So velocity is equal to 0 at extremes of motion. So that's both ends. So it's that's when it's kind of changing its direction, right? So it has to slow down to 0 and then start turning around. All right, what about when is its velocity and maximum? So this is where you might want to look at the blue curve.
Where's the max?
When the gradient of the curve is 0.
Yeah, so these points here is when it's maximum, right? And where is the green guy at these points? Let's slow it down a little bit.
Pretty in the middle.
In the middle, right. So at the center of motion, you can see, let's move it back a tick. Yep. So I'm looking for, okay, when is this going to be the biggest? So right about there. And you can see that's when the green mass passes through the center of motion. So V is, should I say max? V is the, how should I say this? Maximum?
Yeah, no.
Maximum at, yeah, so maybe the magnitude of V. I don't know if that's even at the center of motion. Or the velocity is the fastest.
Could do the magnitude.
Yeah, I kind of want to do that, but I don't want to confuse you guys with vectors. I don't know. Yeah. So I think you guys know what I mean, right? Okay, so V is maximum at the center of motion. So I think that's pretty much all the velocity properties. So let's move on to acceleration. All right, so acceleration, let's model this guy out. So we're back to our closed curve now. Obviously, it's a negative one, right? So again, thinking about sort of the green mass in relation to the orange curve. I can slow that down after 1 second. But in particular, like when is it 0, when is it maximum, that kind of thing is what we're looking at. So let's slow it down. Any ideas?
Pretty much inversely.
Yeah?
Like does what the ball is doing.
Okay, so what happens at, yeah, so what happens at like,
Its max acceleration
yeah,
is at the center of motion. So
right? So let's see, have a look. Two.
Oh, sorry, yeah, so the like 0 acceleration.
Zero acceleration is at
Center of motion.
the center of motion, yeah, and then its maximum would be at the extremities. Yep, cool. So let's jot that down as well.
Interesting.
So acceleration, how should we say that? Acceleration is, I don't want to say maximum. Maybe I should say the greatest at the extremes. and acceleration is equal to 0 at the center of motion, okay? So all of these kind of properties here will be very useful, just like with projectile motion, like they'll get you to recall these facts here in order to solve kind of different problems related to that. Questions about that? Yep. Oh, good.
Projectile motion isn't usually harmonic, though.
Sorry, as in like, you know when we had projectile motion, it's like when is the maximum height? Yeah, sorry, not that they're the same. It's like you need to use those properties to solve problems. So like when is the maximum height, you look for when the velocity is equal to 0. You kind of solve these kind of things. Same idea here. So we need to use these properties to actually solve some of the problems sometimes, okay?